Welcome back, guys. We are still doing transportation problem, and we are going to use northwest corner method to solve this first. Then after that, we do the least cost and the voucher approximation method. So we solve this starting from the very first cost that we have in our board. So in the previous video, we discuss the reason why we start with this first whenever we are talking about the northwest corner method. So in this place, we have the unit A, they have 40 goods, and in this store, they need up to 100 goods. So we supply to them 40, which we have in the unit A, and then we check how many do we have remaining here, 0. So we rule that out, and then we in the store, what are they demanding? They are demanding 100, but you are giving them 40, so what is left here will be 60. So and then this place I'll be taking out, we have just this. Right now we go to the next number in the same row. We have in unit B, they have up to 70 here, and then there's the store one is demanding for 60 goods, so we supply them 60, and then we check how many do we have left in B. We have just 10 goods remaining here. I'll have 0 remaining here, so we'll take out this from our table. So we have satisfied this and A. So we get to the next number, which is 4. So in this place we still have 10 remaining here. So how many does the second store need? They need up to 60 goods. We'll have only 10 here, so we'll give them 10, and then we check how many is remaining here. We'll have 0, so we'll take out this place, and then we check how many is remaining here. We have 50 remaining in this place. So what do? We go to the next number, which is 7. So from here we are supplying with C, and then we are going to supply first to the second store, which they still have 50 goods in demand. So we'll give them 50, and then subtract from our 50 from the goods that we have here. We have 70 here, and then here will be remaining 0. So I have 0 demands for here. We take this out, and then the next place that we'll go to is the sixth one. Sorry, we still have goods remaining in C. So I have 70 here, and this place they are also demanding for 50. So what do? We give them 50, and then we check what is remaining here. We have 0 here, and then we roll this out. So we've taken out 50 from here as well, so we have 20 remaining here. And so we go to the next number here. We have C and 4. So C and 4, we have 20 goods remaining in C, but number 4, they are demanding for 70 goods. So we give them the 20 goods that are here. I have 20 here, and then we will remain. They're still demanding for 50 goods. They're right here. We have already exhausted what we have here, so we'll remove this from here, and then we'll have only this place remaining. So, and there is 50 goods remaining here, and there are 50 goods remaining here, so we just supply them the remaining, and then that will be it for the northwest corner method. So we calculate our total transportation costs. The total transportation cost after using the northwest corner method will give us 4 times 40 plus 6 times 60 plus 4 times 10 plus 7 times 50 plus 6 times 50 plus 3 times 20 plus 4 times 50, which is 1,470. So I'm going to write it up here. We have northwest corner method, NWCM, we have 1,470. 70 for the northwest corner method. So we are going to still solve this using the least cost method and also the Vogel's approximation method. We are going to solve the same problem using the least cost method. And please, if you are just watching this video, if you have not watched the previous video on transportation, please do where to watch it, because that's where I did more explanations on this topic, transportation problem. So let's continue. How do we solve the least cost method? In the least cost method, it says go through all the costs in your table and then pick the smallest cost that we have. Right here we have 3. So, and all through the table, the smallest cost that we have here is 3. So we have 3 smallest cost here. So this is, I mean, 2 smallest cost here. We have 3 here and we have 3 here. So it doesn't mean much. We just pick one of them and then go with it. So let's pick this one that is here. So have in this place we have 3 in the supply unit, and we have, I mean, 70 to supply, and we have just 50 that they are demanding. So we give them 50, which is the least between the supply and the demand. Then after giving them the 50, we subtract from here, we have 0, and when we take out 50 from here, we have 20 remaining here. So it means that we have already satisfied the demand of this place. So we rule this out, and then we have after that we check out for the remaining costs in our table. So the remaining cost, we have this, and then we check what's the smallest 3. So have 3 here, and then we check what is the demand for this place. We have 70 in the demand unit, and then for the supply we have 120. So what do we do? Supply 70. So supply 70 here, and then we have 0 remaining here. I'll have 50 left for us in this place. So we have already exhausted everything here. So we removed this row, and then we check for the remaining costs in our list. So the remaining cost, we have 4, which is the smallest here. So 4 is the smallest cost in this place. I'll have up to 3 of them. So what do we do? Let's first pick this and supply to this place. So we can pick, can actually pick any of them. You can try to use another one apart from this, but we'll still arrive at the same answer once it is the least cost method that we are using. So let's pick this. In this case, we have 40 to supply here, and we have 100 to that are demanded in this place. So we supply 40 to them. So here we have 0 remaining. So we remove this line, and here we have 60 remaining. So what do we have left? We just have this left, and then we go to this place. We have 60 demanded, but they have only 20 that they need. So we just give them 20 supply, and then subtract it from here. We have 40. So here we have 0, and then we remove this column because there is nothing here left here. So what is remaining here? We just have these costs that are remaining. What's the least among them is 5. So right here we have is under this, so we have 50 in the supply unit, and then the demand, they are demanding 60. So give them the 50 that we have here. We have 50, and then we have 0 remaining here, and we have 10 remaining here. So we'll take out this place because there is nothing left here. So what do we have left? We have just 7 and 7. So we'll pick anyone that we want because the 2 of them are equal. So let's just pick this, and then we'll have 50 here and we'll have 10 here. So we'll supply 10 to this place, and then this place is already exhausted, so rule it out. I'll have this, I'll have 40 remaining here, so we just supply, we have 40 here also, so we supply 40, and that is it for the least cost method. So we are going to just calculate our total transportation cost. So the total transportation cost using the least cost method is 1,200. So I'm going to write it here, and then the next thing we use the virtual approximation method and see what we'll get. So right here we'll have 1,200. Yeah, so right now we are going to do the same example using the virtuous approximation method. Just the same way we did in the previous video, just going through the rows, each row, find the two smallest costs, get the difference, write it out, and go through the same each columns, find the two smallest costs, find the difference, and then write them down. So we start with the first row. Right here I have 4 and 5, which are the two smallest costs in our table. So we subtract them. 4 minus 4, remove 4 from 5, we have 1. And then we go to the next row. Right here we have 4, 4, 7, 8, and the two smallest costs here is 4 and 4. So the two of them are equal. When we subtract them, we'll get 0. Now have 0 here. Then we go to the next row. 5 and 3 are the two smallest costs. We subtract them, we'll have 2, and then get the difference in the last row, which is 1. 4 minus 3. Then we'll go through the columns and get the difference as well. So right here we have 4 and 4, which is 0. And then the next one is 1, 4 minus 3, and the next one here is 3, 6 minus 3, and then we have 5, 8, 4, which is 5 minus 4, 1. So after getting our differences through the rows and the columns, we check for the biggest difference, and the biggest out of them is 3. So we pick this 3, and then because we got it from the column, we go through that column and then check for the smallest cost in that column, and then the smallest cost in this column is 3. So we first satisfy whatever we have there. We have the supply column, we have 120, and then the demand, they're demanded for 70 goods. So we supply them with the smallest of them. We have 70 and 120, and the smaller one is 70. So we write 70 here, and then we check our supply. We have 120 here, our supply 70, so what will be remaining here is 50. So we have 50 here, and then go to this place, we have 70 here, and supply 70, so we are not going to have any other goods remaining here. So remove this row because everything here has been satisfied. So remove this row, and then we check again, we go through the rows and the columns again and get the differences. So for the rows, this will still be the same because we have not touched any number here. So we still have 4 and 5, which is 1. Right here we have 4 and 4, which is 0, and then we subtract from here, we have 2, 5 minus 3, and then right here there is nothing left here, so we have dash here. And then we go through the columns again and subtract. Right here we still have 4 and 4 as the smallest cost here, so we have 0 here, and then right here we have 4 and 3, which is 1, and then right here we have 7 and 6, which is the smallest among the ones left, so we have 1 here. You get the difference here, which is 5 and 5, so here will be 0. And then we have gotten the differences both from the row and from the column. So which one is the biggest among the differences? We have 2 here, and 2 is the biggest, so we pick this difference. Right here we have it along the row, so we check that row, and say for the smallest cost here is 3. So we supply to this place. Right here we have 70 goods in the supply and we have 50 in the demand. So what are we going to supply them? We'll supply them with 50 and then check for this place. You supply 50, so we should have 20 remaining here. So 70 minus 50 is 20, and then there's nothing left here. I have 0 here. So we have consumed everything that we have here, so we are going to remove this row as well, and then we check for the remaining ones. We have 50 here. So check the remaining cost and go through it and check for the differences again. So right here we have 4 minus 4, which is 0, and we have 6 minus 4, which is 2, and then we have 7 minus 7, 0, 8 minus 5 is 3, and then right here we still have the same thing here. We have 5 minus 4, which is 1, and 4 minus 4, which is 0. Right here there's nothing left here, so we have dash here and the same thing this place. So we check the differences here, and that's the third difference that we got. The biggest is 3, so we have 3 here, and then we'll go through this column and check for the smallest cost in this column. Smallest cost is 5, and right here they need 100 goods, but what is this place, they need 100 goods, and right here they have 50 to supply, so we supply them with the 50. We have 50 here, and then subtract from here. We have 50 remaining here, and then right here we have 0, so remove this column. So after removing this column, we have just this left, and still we get our differences again. So right here we have 0, we still have 2, and we have 0, and right here we have dash because we have removed everything here, and right here we have 1, 0. Oh no, this place is supposed to be 2 because we have removed this, so we have 6 minus 4, which is 2, and then right here we still have 4 and 4, which is 0. We have removed this place, so, and that's it. So check through the biggest difference. Right here we have 2, and we also have 2 here, which are the 2 biggest difference. So we just pick one of them and use them. So let's go with this. We have 2 here, and then we check what's the smallest cost in this row. So the smallest cost here is 4, and we have 4 here. So we check what's the supply, 40, and what's the demand, 50. So we give them 40, and then subtracting 40 from here we have 0, removing 40 from here we have 10 left, and then this place have been, so we remove this place, and then we check for the differences again. So we check for the differences. We have nil here, and then right here we have 2, right here we have 0 and dash. So check for this place. Along this line we have just this and this left, so we have 1 here, and right here we have 3, and then this and this. So the biggest among the differences is 3, and then we go through this row. The smallest cost is 4, and then what do they need? They need 60, but what is left here is 20, so we give them 20 out of what is remaining. So right here will be 0, so remove this row, this column, and then we have 40 left here. So we just have only 2 routes to follow here. So get our differences again. Here will be dash, and here will be dash. I'll just wipe up this place and then continue. We have this, and right here we have exhausted here, so we have 0 here, 0, and right here we have nothing left. So there is no other cost, the only one cost is here. So write it out. We have 7 here, and then we also have 7 here, dash and dash. So the biggest among all the differences that we got last here is 7, and then so we just pick one of them and supply to it. So let's go with this. So supplying through this row, there's only one cost left here, so we'll just supply to it. We have 10 here, and here is 50, so supply 10 to this place. So we have removed everything here, and then we just have this, and right here we'll have 40, and after supplying 10 here, we just have 40 left. So that's the last one, so we'll just give it, just apply it here, and that is how we do the Vogel's approximation method. So I'm going to just wipe up this place and then do the total cost so that we'll see how it varies with what we have up there, the northwest corner method and the least cost method. The total transportation cost for the Vogel's, using the Vogel's approximation method, we still got $1,200, which is the same thing with the least cost method. So that's not always the case, but we have seen the difference and how far to use the least cost method, the northwest corner method, and the Vogel's approximation method. So we ending this video right here, and the next video will be doing the assignment problem and special types of linear programming problem. So thank you for watching. See you in the next video.